Hello friends, I am Dr. Rajiv Misra, Associate Professor, Department of Computer Science, Indian Institute of Technology, Patna. I am offering an online certification course titled Advanced Graph Theory under NPTEL run by MHRD. Graph theory is a delightful playground for the exploration of proof techniques, its results and applications in many areas of computer science, social networks and natural sciences. In this course, no previous knowledge of a graph theory is assumed. Many algorithms and applications we have included, but focus is on understanding the structures of the graph and the techniques used to analyze the problems in the graph theory. Some of the applications of a graph which will motivate you to go and take up this particular course are such as how can we lay the cable at a minimum cost to make every telephone reachable from every other. What is the fastest route from the national capital to each state capital? How can n jobs be filled up by n people with the maximum total utility? How many different layers does a computer chip needs so that the wires in the same layer do not cross? How can the season of the sport league be scheduled into a minimum number of weeks? And so on and so forth. Königsberg bridge problem in 1736 has given the birth of this graph theory. So, the Königsberg city was located on Prigel river in Prussia. The city was occupied the islands plus areas in both the banks. These regions were linked by 7 bridges. The problem is the citizens wondered whether they could leave home, cross every bridge exactly once and return home back. This particular problem was posed in 1736 by the mathematician Euler. What he did is he has presented it as the model, and that model he called is a graph model, wherein the vertices are represented as the regions and the edges are nothing but the path or the bridge between the connecting these two regions. Hence, on the right side of the diagram you can see that the entire map of that Königsberg bridge problem is represented in a form of a graph model. This particular graph, once it is modeled, then it can be inspected to see whether such a tour is possible or not, and that tour is now famous as Eulerian tour, or that is possible if the graph has those properties, and those graphs are called Euler graphs that we are going to discuss in the course. Graph as a model in different applications is being used. For example, how can n jobs be filled by n people with the maximum total utility? So, we can represent the people as the dots and the jobs also the dots on the other side, and how these particular dots are being connected. So, for example, not every job a person can do. So, the people who can basically be eligible for a particular jobs, those particular dots on the other side is being connected by those set of peoples. Now, the idea is how to fill up these particular m jobs by m people so that it will give the maximum utility. So, this kind of problem can be modeled in a form of a graph, and such graphs are called bipartite graph that we are going to cover up in this part of the course. Another problem is called a scheduling problem. So, for example, there is a need to schedule the Senate meetings without any having conflict of the members or a common members, and also we want that this particular scheduling of all the meetings is to be done with a minimum number of slots. So, basically this particular problem we can model in the form of a graph, and we can solve and using the graph coloring problem. Another related problem is basically posed when you are going to color the maps. So, maps can be colored so that no two adjacent regions or a neighboring region should receive the same color. Now, the question is, can it be colored with the 4 different colors or not. So, that we are going to discuss in this part of the course. Similarly, another application is finding out the routes in the road network. Also, there is a related problem which is called a traveling salesman problem, which visits all the cities, and you want to find out that particular tour which will minimize the total travel cost. So, graphs are evolving, or graphs can be used as a model in many applications. For example, if the application is the communication network graph, then the node can be modeled as the telephone or a computer, edge is a fiber optic cable. Similarly, in a transportation network, you can also see that the nodes are nothing but the street intersections or basically different airports, and the edge or the arcs are nothing but it is representing the road segment or a highway, or you can also connect it with the airline route. Similarly, internet also can be represented in a form of a graph, wherein class C network is represented as a node and the connections at the edges are nothing but how they are being connected. Social network also, wherein the node represents the people and the edge will represent their relationship or the friendship. So, that means all these things we have seen in the real life, and now how different problems in these kind of applications are going to be solved in the graph theory that requires a good theoretical understanding. So, advanced graph theory focuses on the problem solving using most important notions of a graph theory with an in-depth study of the concepts on the application in the field of computer science. This course provides an in-depth understanding of graphs and fundamental principles, models underlying the theory, algorithms, proof techniques in the field of graph theory. So, emerging applications of a graph theory in computer science domain will be covered for significant impact. Upon completing this particular course, students will have the intimate knowledge about how the graph theory play an important role to solve technology driven and research oriented problems. The course content goes like this. So, we will introduce you the graphs and the important type of graphs like path, then cycles, trails, walks, and how these particular different graphs are going to solve different problems that we are going to see here in the basic concepts. Then we will introduce a special type of graph which is called a tree, and how this tree will solve the optimization problems that is basically covered in this part of the content. Then another problem is called about matching, how n different people can be matched to m different jobs, so that all jobs solve those problems are called a matching problems. It will arise in all other different areas also applications that we are going to cover up. Connectivity is also very important. For example, if you lay down a network and if one link goes down or one node goes down, so that particular property is called connectivity. So, we are going to discuss the connectivity and network flows in this part. Another problem is called coloring. Scheduling meetings and all those things will basically be solved with the help of coloring, vertex coloring, then edge coloring, all these and enumeration types we are going to cover up in the coloring. Planar graphs is basically graphs in which can be drawn on a plane. For example, a map also is called a planar graph. So, such graphs, what are the properties it should have, all these parameters we are going to cover up in this topic. Similarly, the edges and cycles. Now, as far as the problems of the vertex coloring you can solve in the form of edge coloring also, if you convert the graph in a line graph and then perform this vertex coloring, and that becomes an edge coloring. Now, another important related problem is called Hamiltonian cycles. So, Eulerian cycles, wherein the edges, if it is traversed exactly once, they are called Eulerian, but if the vertices are to be covered exactly once, then it becomes a Hamiltonian cycle, and the optimization problem is traveling salesman problem that we are going to cover up in this part of the course. So, the required reading in this part of the course would be a book which is given by Douglas West, and all other books which we have listed will be used as the reference. During this course, assignments will be given to the participants for problem solving, and submitted assignments will be evaluated at our end. At the end of this course, an examination will be conducted for those who are interested to get these certificates. I hope to meet you in this course. Thank you.